Hello, my name is Colin Doyle, and I'm a Senior Systems Engineer at Juniper Networks. This is the sixth video in a series that demonstrates to the viewer how to install, configure, and operate a Juniper SD-WAN test environment on their own laptop or desktop computer. In my previous video, we logged into the CSO SD-WAN portal for the first time and provisioned our VSRX gateway. This video is all about policies and monitoring. We'll start by creating a LAN subnet so that our RPI client can connect to our SD-WAN gateway. Then we'll define some basic policies to allow internet reachability and fire up our web traffic generator. Finally, we'll create and verify a local internet breakout policy for a specific destination. Let's begin. Before we log into Contrail Service Orchestration, first need to make sure that our RPI client's powered up. I've already powered mine up to save some time. If you haven't powered yours up, then pause the video and do so. We get in here and run ifconfig. We can see that I don't have an IP address, and that's because we don't have a LAN segment defined on our CPE yet. So that's what we're going to do. If this is one of your first or second videos and you skipped over the lab component videos, this part might look a little odd. I do cover the internal versus external CSO portals and multi-tenancy and swapping between tenants bits in another earlier video. For most people, this isn't going to apply. You're going to log in, you're going to have a URL that you're provided, and you're going to go straight to your own tenant. So if you have any questions about that, just toss them in the comments below. So let's go to resources, and then if we're under site management, we should see the spoke that we onboarded, and there it is. If we go to LAN, we'll see that there's nothing there, so go ahead and click the plus, pop up a screen. Name our LAN segment. I'm going to name mine client net. I'm going to give it a VLAN ID of 71. This is the same VLAN that I defined earlier when we set up our RPI client system. And like I said in that video, you can use any VLAN ID that you care to use. It's all self-contained within your lab. It just needs to match the VLAN that we've defined on that other device. I don't need to create a department, but I'm going to show you how it's done. These are logical containers that allow you to create policies that group together like roles. A good example might be if you have a wireless and wired like corporate network traffic kind of thing, where you're going to have the same policies that apply to wired and wireless connections for a particular group of folks. That you don't want to have to write two policies for everything. You just want to write one. Enable DHCP because I obviously want my client to get an IP address. Give it a little small range here because it's only ever going to give out one IP. Find some name servers. And then we're going to add this GE002 interface. Go ahead and save that. Once we see that this site's modeled, then we can go ahead and deploy it. On that, and then click deploy. Then we want to watch this until it actually completes. This can be a little bit misleading sometimes. The single source of truth here, and we'll see that get configured. It'll go into a deployed state. We want to monitor this from the jobs. If we attempt to create our policies before this is complete, we will get some error messages. They're trivial. You can just redeploy your policy once the LAN network is deployed. But if you skip the headache here. So we're just going to keep an eye on this. In the meantime, hey, let's go look at some RBAC stuff. Got some time to kill. If you needed to create specific roles for specific users, maybe you have a NOC that's going to be taking calls and you want them to be able to see the network but maybe not make changes to it. You can come in here and define roles for different folks. We have some predefined roles, and then we have the ability to create a new role. And these are, if you've ever done RBAC in Junos, you know that there's a lot of options here where we can break any of these out and get really granular with the type of access that folks have. And you can create those roles and then create users and assign them to those custom roles or any of the predefined roles. it's pretty cool. All right, let's see where we're at here. Yeah, still in progress. We got the add, we got the deploy. We're wait for that to finish. Our next steps, just to kind of get ahead of it here, we are going to create a policy that will allow internet connectivity, and then we'll wrap up by creating a breakout policy so that we don't have to go over the tunnel and to the hub to get to the internet. I think that there's a use case for a lot of folks where, if your traffic's just going to go out to the internet, this is a security appliance, you might as well send it out locally and spare your tunnels the traffic load. If we have more time here, if this isn't done, then we're going to let's talk about how this is priced. Imagine some people at some point or another are going to say, all right, this is cool. What's it cost? Well, I can say that from a costing standpoint, it's competitive. I'm fond of telling people that if you want to buy our SD-WAN solution, we're going to lose on price. As far as how the licensing is structured, I like to think it's fairly straightforward. Essentially, we take all the firewall products and we divide them into 3 classes of device. We've got devices you can put in a small to medium-sized branch, we've got a medium to large-sized branch, and then we've got hub devices, A, B, and C. And the licensing for CSO is based on what your use case is. SD-WAN is the one we're looking at here. We also have next generation firewall as a use case, SD-LAN for campus switch management. So depending on which of those feature sets that you fit in, combined with the class of device that you're using, that's how the licensing works. The license includes the right to use for the CSO portal. It includes the support for the SD-WAN service if you happen to have any kind of issues. And then you just layer that on top of your hardware and the support with that hardware. And that's it. N+1 until you're done. All right, I'll show you why this can be tricky. Maybe it'll show us. If we go to the spoke here, you'll see the LAN says it's deployed. And that is true, actually. There are still some back-end things that are being done within the system here as part of that LAN deployment. And if we start to try to layer policies on before this wraps up, it'll complain. And again, it's trivial. You just wait until it finishes and you run that process again. But if we look here, nothing yet. Oh, wait, it actually did grab it. Perfect. And I can probably ping that gateway as well. But you'll also see that if I do a ping to the internet, it does not work. And that is just because we do not have a policy that allows it yet. So this won't take too much longer, and any LAN segments that I would deploy after this actually take a lot less time. This first one can just take a minute, which is maybe an argument for doing this when you actually deploy the site itself. I think for the sake of showing folks how this is done, it's a little bit better to do it separately as a separate action. But I'll go ahead and pause this here and we'll come back when this is wrapped up. And we're back. Bit of an air gap there. My day sort of got away from me, but we can get back to this. Where we left off, we were able to ping the gateway, but not out to the internet, so we need to create a firewall policy. Now, the routing is there already. What we don't have is a policy that allows communication that originates from within our LAN out to the public internet. We have a default policy here. I'm going to create a new one. The policy is just a bucket, so we just need to give it a name here. We'll just call this SD-WAN and set it up for all sites. This allows us to create intents, which you might know as terms if you're in a firewall device. This allows us to segment policies, so if we have different use cases for different sites, we can create intents specific to those sites. Oh, wrong one. Back, please. We'll add an intent here, and this will be a very straightforward HSI, high-speed internet access. I should just call it internet. Our source will be the client department that we just defined. I'll stretch the screen so that action and there we go. Of course, you could define anything you like in here, but we're going to define the client department that we just created for our network. And we'll do it any because we want to make sure this can get out to anywhere on the public internet. And we'll enable logging. We don't have any advanced security. This is where you would apply any sort of UTM features like web filtering, antivirus, anti-spam. So go ahead and save that. It'll model the intent. Once it's there, we can check the box and click on Deploy. Get that running. Now, once this deploys, we will be reaching the internet through an encrypted tunnel over the overlay back to the hub that we're connected to. And this is where whether or not you define a default link becomes relevant. I'll show you what this traffic looks like once this policy deploys and we're able to reach the internet. I'll set up traffic generation, and we can look at that within the tool. It's important to know that it does go back to the core or the hub, because we're going to do a breakout policy next. It'll allow us to break out to the public internet over the local underlay. And I think for a lot of folks that's probably preferred because it'll keep traffic off of your high value WAN connections back to your core and just put traffic that's going out to the internet straight to the internet. All right. And hey, look at that. So now that that's done, from the root directory, and if you didn't join us for the video where we deployed this client testing machine, we cloned a Git repository that contains a Python-driven web traffic generator. That's actually here in this folder right here in the root directory. I'll quickly cat the config file here so you can see how it operates. Essentially, you can define some root URLs, and then it'll create a pause and click into each of these. You can go in and edit this file if you like. I'm not going to for now. I'm just going to run the Python script. And what this will do is allow us to generate, before I turn that on, I'll get over to this screen. It'll allow us to start generating some actual traffic on the link. So you can see here, I don't actually have any data available. Now this isn't instantaneous. There's going to be just a little bit of lag, but it won't take too long. So while we're waiting for traffic to show up, I'll show you the other places we're going to be poking around. The traffic will end up here. When we want to get maybe more detail, we can click on the different, actually there'd be a bar graph, and we'll be able to click on specific detected applications, web services, and such. We can also go to monitor, go to application visibility. This will throw up a bubble graph. This is showing us stuff that happened in the last day. As I've been doing testing on this, if I cut it down to like the last 30 minutes, it's probably going to get pretty boring. Yep. So we'll see that information here as well. And we can also go to resources. And when we go into the spoke, this is where we can see where that traffic for that local spoke is actually transiting. And this is why I like to define default links, because it makes this information very binary. So we can see that our connection to this hub, if I click on that, it'll break it out. We'll have our primary is basically WAN 0 and our backup is WAN 1. We can see these top applications here. This might actually mean that we're already starting to clock some application traffic. So, yep, and there's our spike in utilization. So let's go back to the dashboard and see if we see some information here now. Yep. Now this will get far more interesting as time goes on. This will refresh every 2 to 5 minutes. I think it's the, let's see here. Yeah, I've got it set to 5, okay. So as we go on, this will get more interesting. But what I really want to show right now is that it's going over the primary link and not the secondary link, or the overlay and not the underlay. So click on here, break that out. Click on WAN 0. And we can see a spike in traffic there. We see this information. I go to WAN 1. We really don't see anything. You can see that there's nothing going over there. Now this is the overlay. If we look at the underlay, and this is where the breakout policy will come in. We're not going to go into link switching until the next video when we do SLAs. But if we look at the underlay, we'll see there's no data available there because everything is being tunneled at the moment. So let's go see if the dashboard looks any more interesting. I have to wait a couple minutes for this to really start stretching. But actually, you know what? I'm going to pause this here, and we'll come back in like 5 or 10 minutes so that we've actually got some more traffic here. You can actually see what this looks like. It's pretty cool. Okay, this is getting a bit more interesting. Here we can see the websites that the traffic generation is attempting to touch, click into. It seems to be working fairly well. So let's see here, what's being used the most? Yahoo. So let's break that out. Now typically, actually it depends on if I have a signature. I'll explain how this works along the way. So a breakout profile, 9 times out of 10, at least in my experience, is going to be used to break traffic out just to the internet. You're not really going to be granular with the policy. In fact, if you are, you're going to be granular by saying send everything to the internet and then identifying specific applications or destinations that you want to tunnel back to your core over your backhaul. So what we'll do here is we create a breakout profile, and that just doesn't care about the application at this point. It just simply defines an action or behavior. So in this case, the action or behavior we're going to define is local breakout over the underlay. Backhaul is if we want to send something back to the core. Now, right now we're doing that for all traffic, but if we create a blanket policy that breaks out everything and we want to send certain traffic through the backhaul, we would create a second policy and to use to apply in the policy itself. And then we also have the cloud breakout here. I think you probably saw the Zscaler default policy that comes sort of predefined. So we're going to do local breakout. We'll just give it a name. We'll say local-bo. This traffic type profile, generally you can ignore. I mean, pick the one that kind of matches your traffic. This has to do with QoS values on the underlay. This really only matters if your carrier is doing any kind of prioritization for your underlay. And generally, you'll see this maybe with MPLS using EXP bits. That's actually essentially what this is that you'll select internet, and that means it will apply the appropriate EXP bits to the traffic on the underlay for that particular traffic. In our case, it doesn't matter because I'm not using any of that. Those bits will get added and my carrier won't care. So I'm just going to pick internet. There's more information on this. I don't want to get too deep into it. You can talk to your account team or ask questions below if you like. So we've created an action. Now we need to define a policy. So in this case, we could say all sites, but let's be a little bit more prescriptive. We'll say client. And I don't know if there's Yahoo in here or not. Let's find out. Hey, look at that. Cool. So again, you could do all. For just the sake of coolness, I'm just going to do Yahoo so we can see that. And then I'll select a profile here, local breakout. As long as the application can be cached, then we can be really granular there. And there's more information about that. What I mean to say is you can't locally break out granularly every single application that we list. It really depends on our ability to identify it and cache it while we're doing the identification. Some things that just doesn't work with. But if you do any, it'll just grab everything. It doesn't need to cache, it just knows. So that's done. We do need to deploy it. So let's deploy it. Now what we're going to be looking for to prove that this worked, our traffic generation is still running, is we'll go back to our gateway and we should see Yahoo traffic on the underlay. That's the test here. So I'll wait for this to finish. And as soon as we see that, we'll know it's worked. And that will wrap this video. All right. Okay, looks like we're good. Task complete, task complete. Perfect. Okay, so go back to resources here. Go to our spoke, WAN. Go to the underlay. And we might need to give this a minute, like we did when we first turned this on. We can see now it does say local breakout. This was a no before. Might be able to goose this a bit. We said Yahoo. Let's just go to Yahoo also. And there we are. So we've flipped our Yahoo traffic over to the local breakout, and everything else is still running over the overlay. Terrific. So that wraps up this video. The next video will cover SLA, policy creation, link failover for applications. It's the last video that I have planned for this series. I expect that there will likely be more. They'll get into some of the more granular, maybe custom application IDs and such. But if you've been with us the whole way, or if you've just joined for the last couple videos after the onboarding, we're almost there. Once again, thank you so much for joining me. If you have any questions, please reach out to me directly. Leave them in the comments below. I'll do my best to answer them. Thank you so much for your time. Take care.